The properties of an acid are when reacted with zinc, magnesium, and aluminum, they form a hydrogen ion, which is an H plus ion. They react with compounds CO32 minus, which is carbon dioxide, to form carbon dioxide and water. It will turn a litmus paper red, and it tastes sour. An example would be a lemon. It is a citric acid, a weak acid, but an acid nonetheless. Now a base is a substance when added to water will form a hydroxide, which is an OH negative. The properties of bases are that it will feel soapy and slippery. It will turn litmus paper blue. It will react with most cations and precipitate hydroxides. And it will taste bitter. An example would be if you've ever gotten soap in your mouth when you're taking a shower. You already know the taste.
Hello, my name is Jesus Loreto, and I'm going to be teaching the difference between strong acids and strong bases. First of all, the terms strong and weak do not refer to the concentration of the acid or base, but instead refer to whether the acid or base dissociates completely in water. The common strong acids are hydrochloric acid, hydrobromic acid, iodic acid, nitric acid, perchloric acid, and sulfuric acid. The common strong bases are the alkali metals bases and calcium hydroxide, strontium hydroxide, and beryllium hydroxide. Any other acid or base is a weak acid or base. In an acid-base reaction, an acid plus a base reacts to form a conjugate base plus a conjugate acid. The conjugate acid of a base is formed when the base gains a proton. Referring to the following equation, we say that NH4 plus is a conjugate acid to the base NH3 because NH3 gained a hydrogen ion to form NH4 plus. The conjugate base of an acid is formed when the acid donates a proton. In the equation, OH negative is the conjugate base to the acid H2O because H2O donates a hydrogen ion to form OH negative. The conjugate base. Note, the stronger the acid or base, the weaker the conjugate. The weaker the acid or base, the stronger the conjugate.
The pH is a measure of hydrogen ions, concentration H+, and the pOH is a measure of hydroxide ions, which are OH negative. The units for both are moles over liters, and the formula that you use for both, to solve for both, is negative log to the 10th power of OH or H. To check your answer, the pOH and the pH have to add up to 14.
Alright, so this is DJ Acid. Us acids are crazy. So crazy that we make the limited paper red. Look how red this thing is. My God, it's so red. Not only into that, but whenever we check the pH level, it's below the number 7. Anything below the number 7 is acid. Anything is acid. Like for instance, this lemon. Ah! Ah! Oh my God! Oh! Oh! Yeah, I thought you said they were fake lemons. Can someone go get me a pending? Cut it!
Alright class, this is how to properly exchange the base. Alright, this is DJ Base. The difference between a base, the litmus paper is always blue. The pH is above 14. A perfect example is of soap. It's slippery. God dang it. It's wet. And it's all bitter. And this is a base.
And have some bacon to it!
Stop beating your meat, Josh. I'm trying to...
Well, hello class. How you doing today? My name is JJ Hansen. As you've seen, I have been properly prepared for this occasion. Oh, let me just tell you about what we're going to be learning today. We're going to be learning about the conjugate base and conjugate acid. Well, what is a conjugating base and conjugate acid? Let me just tell you real fast. It's whenever the equal gain or loss of a proton between the pair. So whenever I mean between the pair, I mean the conjugate base and the conjugate acid. Let me just show you by demonstration. Alright class, so first off, I want to say that we're going to write NH3, which is ammonia, plus H2O, which is, as you know, sexy water, which is yield to NH4 ammonium, plus hydroxide. After that demonstration, let me show you another example. Of course, you may be asking, why is my hand black?
So to calculate the pH of an acid, we use the formula of pH equals negative log to the 10 H plus. For example, to find the pH of 0.2 molar liters of HCl, first you write the balance equation of HCl, which is presented right there in the middle. Then you plug it into the calculator. Negative log 10.2 gives you 0.7. And that will be your answer to find the pH of HCl. So to calculate the pOH of a base, we use this formula, pOH equals negative log 10 OH minus. To find the pOH of 1 molar liter units of NaOH, sodium hydroxide, first you write the balance equation. Then you would plug it into the calculator as so. pOH equals negative log 10.1 equals 1. And that would be your answer for pOH.
Review! The difference between an acid and a base is that when acid is added to water, it creates a hydrogen ions. And when a base is added to water, it creates a hydroxide ion. An acid will turn a litmus paper red, and a base will turn a litmus paper blue. An acid is sour and corrosive, and a base would feel soapy. Is that about it?
The way you tell the difference between a strong base and a strong acid. The way you tell if whether it is a strong base or a strong acid is whether it dissociates completely in water.
Let me just tell you, class. Remember, conjugate base, conjugate acid, they're both equally lose or gain pairs. A proton with it pair. Remember, class.
So to calculate the formula of an acid, the formula would be pH equals negative log 10 H plus, and the formula of a base would be pOH equals negative log 10 pOH.